In this short presentation, I would like to talk about reuse of structure members. My name is Wang Chang. I'm Professor of Structure and Fire Engineering in the University of Manchester in the UK. So many of you probably have seen such an image before. A building has come to the end of its service life. Then what happens? Then the demolition contractors will come on site and then very quickly they will pull down the whole building. In this process, even though it is very cheap and efficient, in this process, then they end up with piles of waste, which mixes all the different materials together. This then makes it very difficult to separate the materials, and then the end result is most likely landfill. Even if you can then recycle the materials, because it is very difficult to separate one material from the other, then the values of these materials are lost, and then it will then create some low value recycled materials. For example, for road use. What I would like to do is then to ask you to think about a recovery or reclaim and the reuse of structure members at the end of the life of a building or a structure. It has always been considered difficult to reuse existing structure members, but they are possible. What I would like to do is then to show you some of the techniques which can be used to recover and reuse various construction materials. I'm going to talk about the most common types of construction materials, including steel, concrete, and then the composite use of steel and concrete, masonry or bricks, and timber, and finally a quick summary of the presentation. So let's then start with steel. Steel is, of course, the most used construction material in the UK, accounting for about 70% of the frames used. And also in the UK, the components or structure members, they're bolted together. For example, if you look in more detail in here, the connection between this beam and this column, they are bolted using bolts. And because they're bolted, then it's actually very easy to recover them or reclaim them. All you have to do is then to unbolt them, and then they are recovered. Steel also then does not change its mechanical properties throughout its life, and thus, of course, is rusted, which means then they don't suffer any mechanical change in any reduction in mechanical properties. Then that means they can then totally reuse them. So technically speaking, recovery or reclaim and the reuse of steel structures is very, very simple. The more troublesome part is really so-called quality assurance, to know where the steel comes from, what material properties they have. And then, of course, then there must be a business model for that, so that then there is enough supply of such materials and there's enough use of such reclaimed materials. But of course, this is already happening. An example of this is the Cleveland Steel and Tubes Limited. Here, then, they have created a huge site to store their secondary steel members reclaimed from elsewhere. So this is a huge site in Yorkshire in the UK, and on this site they have stored tens of thousands of tons of second-hand steel members. At the moment, such second-hand steel members, they are spare, but even they are new tubes, but they are surplus steel tubes which were ordered by clients from offshore industry. So the client simply ordered too much steel and they don't really want to and have no use for them. Then Cleveland Steel, they just simply took them from the clients, stored them on site. So they're actually new tubes, and they say there are hundreds or tens of tons of them. So Cleveland then stored them and then actually reused them in a number of cases. One quite interesting example of the reuse is is the construction of this tree in here, where then the tree trunks they're built using the tubes of Cleveland steel and the tubes. What's so special about this tree in here? Well, some of you may know that the Queen in the UK has been a queen for 70 years, the so-called Diamond Jubilee. A celebration of her 70 years as the Queen, they then built this tree in here, the light tree in here, and then the tree within this light in here is a little tree in here. Then thousands of these little trees will be given to various people in the UK to grow into big trees. But as I said, this big tree in here was then constructed using the second-hand tubes. Now, of course, then these tubes were second-hand and they were still new, but Cleveland steel and the tubes, they also now have grown into the market of recovered steel from other buildings. For example, then this is one of the new office buildings, and all the steel work in here was actually recovered from other buildings, and then are now reused in this building, which is one of Cleveland's own office buildings. So that's then for steel structures, as I said, quite easily recoverable and reusable. Concrete structures are a bit more difficult. If a concrete structure is made of precast members or had been designed for the construction, as the bottom picture in here shows, then they can be recovered. So for precast, you simply then take away because they're simply supported. For this structure, which had been designed for the construction, what they use pretty much bolts to connect this member to that member. So just like unbolting of steel members, you can unbolt concrete members and then reuse them. This difficulty with concrete structures then is that it is not very flexible because each reinforced concrete member has its own dimensions, its own reinforcement, demountable reinforcement. So they can only be used under the same loading condition and same spans as the original application. Nevertheless, they can still be reused. When we come to in situ reinforced concrete structures, then it becomes much more difficult because then for in situ reinforced concrete structures, to reclaim them, then we have to cut them into pieces. Now, because of this cutting, then we're now destroying continuity of reinforcement, because in reinforced concrete structures, we need reinforcement to transmit tension between different parts of the structure. So by cutting that, we then have the cut reinforcement that then destroys continuity. If we don't want to reuse the components or the segments, we then have to recreate this continuity. In steel structures, that can be easily done by welding or rebolting. But for concrete, we then have to use additional components. In this case, in here, a steel plate, another steel plate, and then bolted through. So if we then have tension in this direction, then this bolts in here will then be shear. But this is quite difficult to do because it takes a lot of time to drill holes to install the bolts, and then we may have to install a lot of bolts to create necessary continuity provided by the reinforcement in the original concrete construction. So it is quite difficult then to deal with in situ reinforced concrete structures. That means then the scope of recovery and the reuse of reinforced concrete structures is a bit limited, and then we have to think of totally new ways of doing things. For composite construction between steel and concrete, the difficulty is more dealing with the floor construction. So if we then look at how floor is constructed, what we have is then we have a decking, which is shown here by this gray picture in here. The decking is then welded to the steel section, which is this blue color in here, by using this short fired studs. Okay, so then this then is welded to the steel section to weld the steel decking to the steel section. On top of the steel decking, then we can cast concrete that then to form the floor and the composite beam construction. That's how it is done currently. The difficulty, of course, then when this construction reaches the end of its service life, then it's very difficult to separate the concrete from the steel section. What we have done is that in our research, we have tried a number of ways of separating them. What we found is then to use this so-called wall saw cutting. We have this diamond saw, which is secured, fixed to a wall in here. And then we have this piece of composite beam, which is this one in here. We have steel, we have concrete in here, and in between them, we have a shear stud. So we can use this diamond saw to cut through the interface. And we have tried that. We have found them to be quite feasible. So to cut each one, it takes about 10 seconds. And because of this friction here, it takes a bit of the steel surface of the steel section away, but the amount of surface loss is very minimum, about 0.5 millimeter. So this technology is actually quite feasible to reclaim steel members from composite construction. And as I said before, once reclaimed, it's very easy to reuse steel sections. If you are then dealing with new composite construction, instead of using welded shear studs, you can now use bolts to connect the floor to the beam. So in here then, this is, imagine then a steel section, but instead of using welding, we can use bolts to bolt through them. And of course, once this is then the end of the life of this building, just like unbolting steel structures, you can unbolt this to separate the floor above from the steel section below, and it's quite easy to reuse the steel sections. Here's an example which we use in our research. So these are bolted shear studs. Underneath on this side is steel beam, and then on this side we're going to cast concrete. At the end of service life, then they can be quite easily unbolted, and they have the same performance as normal composite construction. So that's then for composite beam or slabs between steel and the concrete. For bricks, of course, then normally you have to use mortar to connect them together. There are two types of mortar, the so-called lime mortar and cement mortar. Lime mortar, over time, they decrease in the mechanical properties. So after many years of use, then lime mortar can be easily shaken off to recover bricks. But of course, lime mortar is not really used very often. Most of the time is cement mortar. Cement mortar, they don't easily shake off. So what we have done is then we have invented this so-called punching technology. Here then you have two pieces of bricks, and then they are then bound together using mortar in here. So what we then did was then choose a cutter to punch through the mortar. Here's the result of that punching process. Yes, you can see still some mortar stuck on the surface of the bricks, but they can then use as even the new bricks. So that's then easy to do. If you're then dealing with new brick construction, it might be then possible to use so-called mortarless bricks. Here then you make slots in the bricks during the manufacturing process, and then you install these metal connectors in the slots to link this brick to this brick in this direction, and to link this brick and that brick in the perpendicular direction. So at the end of the life of this brick construction, you can then simply easily take away the metal connectors and then reclaim each brick one by one. And then bricks are bricks, they can be easily reused. So that's then brick construction. For timber, at the moment, the difficulty is that then timber is mixed totally together with other materials like brick wall, concrete. So then timber is totally lost in its value. What you can then do is then to separate timber from other materials. So even though in this case, you can't really directly reuse them as structural members, but then it's very easy to recycle this timber and then make use the timber to make into new structural members. If you're then designing new timber structures, you can then employ so-called demountable technologies. Basically, again, you use bolts to connect one piece of timber to another piece of timber structural member, and at the end of the life, just like you unbolt steel members, you can unbolt timber members, and the timber members can be then totally reused in the next life. So as a summary, I want to say that the construction industry has the highest potential for circular economy innovation. Why is it? Because the construction industry uses a lot of materials which has very high embodied energy, but also then circular economy innovation is really only starting to be considered in the construction industry. So the potential is huge. There are, of course, difficulties to reclaim and reuse structural members in buildings, but they are still possible, with the degree of difficulty, of course, depending on the materials you're dealing with. It is very easy for steel, it is very difficult for concrete. For timber and the bricks, the degree of difficulty is in between. So to say, concrete is difficult to deal with, but steel is very easy to deal with. But technologically, it is possible to do all the things which you want to do to recover and reuse any material. Reclaim and reuse may be a bit slower, maybe a bit more expensive than the existing ways of doing things. The existing ways of doing things is by destruction, and then destruction for old existing buildings, and then when they build new buildings, then totally new materials to use them. But with climate change, with the need to reduce embodied carbon, then recovery and the reuse of structural members can become a very important part of this decarbonization of economy. The key in here is not really about technologies. It is possible to do them, as I've demonstrated in this short presentation. It is about creating a market and creating a market for that. Maybe this is something which can be implemented in China a bit more easily than in the UK, and I'm hoping that is the case. And finally, I just want to then show you very quickly a few references based on our previous research, starting with the more broad picture of reuse, recovery and reuse, to more detailed information about various ways of making new construction or demounting or new construction, old construction for bricks, for steel and composite, and then of course so-called stock analysis. So because of time, I'm not going to go into detail on these sort of things. And with that, I want to thank you very much for your time.